Hello there, I'm Chris Benson. I am Chief Scientist for AI and ML at Honeywell Safety and Productivity Solutions, which is one of our global divisions. This is me, this is my intro thing. So I do the top. I used to be with Accenture doing AI. In general, I'm an AI strategist and a deep learning architect. I'm just starting to co-host a brand new podcast called Practical AI. Keynote speaker in artificial intelligence, like tonight. I run the Atlanta Deep Learning Meetup. And I was introduced to AI, deep learning specifically, before it was called deep learning in 1992. And I like to talk to people a lot about this stuff. I started actually programming originally on this thing. For those of you who are old enough, you may remember this. Not many in the room probably do. And these days, I work on this, which is a supercomputer for deep learning. And so I was introduced, as I mentioned, to deep learning 25 years ago. Long before anyone was calling it deep learning. And so this is how it happened. You may recognize this, the F-22 stealth fighter from Lockheed Martin. The Raptor, it remains the world's fastest fighter. But there was this thing that happened when it was in a prototype phase, and one of the two prototypes was being tested at Edwards Air Force Base, and this happened. And it was not good. The Air Force was not happy. Lockheed was not happy. Pilot was fine. But the avionics were supposed to keep it from doing that. And so they had a real problem on their hands. So they turned to this guy, and basically his job was to help solve that problem, which he turned to deep learning, which was neural networks of the day. Happens to be my dad. So he would come home from work when I was younger, and he didn't tell me any of the classified stuff, but we used to talk about neural networks of the day, and I spent about a year in terms of like how he was implementing neural networks, the choices he was making, that kind of stuff, and that stuck with me. And just as a 2-second slide, it's his birthday today. He's no longer with us, but I just wanted to say, hey, happy birthday, Dad. You know, I wouldn't be doing any of this if it hadn't been for him. So he'd be 86 today. So I also wanted to real quick thank, my conference so far has been mostly about Adobe. You guys may have seen in the exhibition hall the tank, and so some of us, and there may be some folks in the room here who were with me, Robbie, I think you're here somewhere, who did this yesterday, which was a live broadcast, and it was a lot of fun. And then earlier today I was in that box and they did a quick interview and stuff. I just wanted to thank Adobe. It was so much fun to do that. So let's move in real quick, and the way I'm going to do this is I have a ton of slides, so I'm going to fly through them, real quick talk about like why we care about deep learning, but then I'll get into delivery as fast as I can here. So deep learning is modern artificial intelligence that works today. In my view, it is the primary thing that deserves the AI moniker at this point. It's an approach to machine learning that draws inspiration from the brain, and it is really what's driving the AI revolution. So, by the way, you may know some of these quotes here. This is from the deep learning textbook, and probably a number of you in the room have been through that, but these guys are really, it is the authoritative text on deep learning. So I make some reference to it along the way. And so we're really talking about a type of machine learning that not only learns from experience, but a whole lot of data. And basically, the cool thing about it is you don't have to have a human operator specify everything about what needs to be done. So you're learning from data without explicit programming. And so deep learning is the modern application of deep neural networks to achieve machine learning. You might think of deep learning as the name of the field, and neural networks are the specific tools that you're using in the field. And this is kind of how they relate. People are always asking about AI versus ML versus DL. This is how I do it. And if you want to throw in data science and big data, you can kind of blend it in that way. And then here's a thing I pulled off the internet, which just shows kind of a time sequence where it was kind of like the early days of AI, what they're calling here were the symbolic days, and we're moving into machine learning and subsequently into deep learning. And really, obviously, machine learning and deep learning are the two survivors. AI is, but not in that symbolic context that was in. So in recent years, we've seen so much growth in this field. And it's really due to the fact that you have more powerful computers, and we'll talk about all this in some depth as we go forward, larger data sets, and new techniques, and that's evolving so fast, as those of you who are in the field now know. But we're talking about deep learning a lot, but why does it really matter? What's the driving force here? I mean, we're all aware of these autonomous cars that are going around, some of both the good and the bad that we've heard in recent news articles about that. I personally am so tired of talking about chatbots this, chatbots that, which has been one of kind of the early implementations of how we might apply some of these technologies in terms of UI context. And then, but there's so many things beyond just cars and chatbots that you can do. Deep learning has really hit just about every industry on the planet. And really, without going through everything here, we're basically talking about security, marketing, computer vision, speech recognition, NLP, transportation, healthcare, and finance. And that's just a few. It's in agriculture. It's in everything. I challenge anyone to come up with an industry these days that there's nobody experimenting with deep learning and how it can make a difference. So it's really pervasive. This is something I stole off of Andrew Yee's website. He put that out, which is just some other ways about how you might look at solving deep learning problems, or solving problems with deep learning specifically. And so it's really becoming a big thing in the enterprise, which is one of the reasons I'm here tonight. I work for Honeywell. I haven't worked for Honeywell that long, but myself and a lot of other people in enterprise are trying to make this stuff work. And so it really started with Google as they were out there, for many years focusing on mobile first. But this guy who's their CEO is now driving AI first, and that's from several years ago now. And the rest of us are really leaping into that. And he says that we're rethinking all of our products and services and applying machine learning and using AI to solve problems. And that's what every other company out there, aside from just those top few, are now doing this. And it's really, really vital. And what that means is that since all industries and all companies in those industries are diving into this, it really means that in the years to come, you're almost certainly going to be consuming. Most of you already have. Probably everybody in this room is consuming microservices that are powered by deep learning. And many of you will also be creating those as well. That is just going to be a part of the data science plus software development world as standard fare going forward. And we'll talk about that going forward. This gentleman here, who's a CIO at this particular company, I'm not drawing him out for any particular reason other than to say he makes this prediction here. And this was about 2 years ago now. So we're 2 years into a 3-year prediction he was saying, if you wait 3 years, you've waited way too long, you'll never catch up. But if you jumped into it 3 years ago, your investment would have been very, very expensive. Now, I don't know for sure what his timeline prediction, how accurate the timeline prediction is, but I do know that the baseline idea he's saying is completely correct. And as I look at it 2/3 of the way into it, I actually think his timeline, I wasn't sure about that for a long time, but I'm starting to think his timeline was pretty accurate as well. And that's really key. And it's not just companies. It's whole countries out there, some of which we struggle with at times in our relations, but this was just on September 1st, and artificial intelligence is the future not only of Russia, but of all mankind, and the industry leader will rule the world. Very Putin kind of comment to make, but really important. He was saying this to a large audience of university students. He's telling them to go out and do this on behalf of their country. So it's hitting everything, political, social, cultural, and every aspect of industry. Not all world leaders agree. Not making a political statement, just having some fun here. So I want to talk a little bit about, we've kind of talked about why it's important at a business level, but what is that secret sauce? Why are we interested in delivering deep learning out there? And I don't see this often. I came to realize this a while back, and it's deceptively simple. Deep learning can approximate any continuous function. And if you're not a mathematician, you just go, oh my God, I'm falling asleep at that. I don't, why do I care about that? But if you think about it, just about everything imaginable involves computing a function. And if you think about that for a moment and the implications and how that scales, that's huge. It means that neural networks are sort of universal in a sense, and they're the first tool of their type. They're certainly the first data science tool that has been universal for very complex problems. So you're talking about a universal approach to solving complex problems. And that is really, really powerful. And we'll talk a little bit more about where they might apply and also where they might not apply as we go forward. I'm just going to skim over. I'm not going to try to teach anyone here deep learning. I'm going to skim over how it works, because when you're trying to deliver it, when you're trying to make it work in your organization, it matters a little bit how it works and the distinguishing factors. So I'm going to talk about that for just a very few minutes. This guy is excited. He wants to leap into it. So training enables generalized predictions using known correct results. And that's a lot of known correct results if you're talking about supervised learning, which is what most of us are doing right now if you're not on the leading edge of research. And frankly, in industry, most of us are implementers rather than researchers. We research in order to get our implementation working. So once trained, generalized predictions come from new inputs. And so basically what you're saying is that training is a search, that you're searching for the set of weights that will give the neural network the lowest global error for the training set that it's training on. And in a toy sense, this is what it looks like. This probably for most of you is very familiar. You have the different arrows representing different weights, and you could say after training, you have to go deploy that out. And in the last few years, as we've come back around, the number of architectures have exploded, and you're probably familiar with this. There's far more than these. These are just some of those common initial ones, which is basically feed-forward networks, which is the granddaddy of them all, and we're still using them today in all sorts of different applications, and they fit into other architectures. Convolutional, which is the classic machine vision approach, although they're finding all sorts of new uses for CNNs today. Recurrent, which give you a temporal basis for how you're going to process information. And there's a lot of cases where CNNs and RNNs, those two, can both be used to solve the same problem in different ways. And then generative adversarial is really where you're talking about creating new things. A lot of the most common thing is people see artwork and stuff, computer generated. The very front of the deep learning textbook, the authoritative text, shows a GAN-produced image on that. And I do a lot of work in machine vision at Honeywell. And this is just a typical thing. I pulled it off the URL at the bottom. Typical image which shows how you're actually taking bits of data, taking pixels and aggregating them together into higher abstractions and ever more into higher and higher abstractions depending on the complexity. And then eventually you do run it through a feed-forward network on the back end to get there. And this is a really common thing, and there's all sorts of variations of this. And we spend, I talked about industry doing research. When we are going out and trying to solve a problem, this is the kind of thing we're doing research on. We pick an architecture, we pick an approach, and we're standing on the shoulders of the giants before us. But then the area that we're researching is, okay, what if I tweak it this way or that way? Do I get better results? And so that's really what you see in industry. And all of this that we've been talking about requires lots of data and lots of computation. And that is really the point that I'm about to get into as we dive into the meat of it. And I'm going to slow down. I've been kind of racing through this first section because this audience is for the most part, fairly well educated on this. So I'm going to slow down a little bit, kind of talk about now how we actually get there, and then hopefully have time at the end for some questions, if there are any. So delivering deep learning, and the next slide is a humorous one, but it's so true. When I'm getting together with people and stuff, I mean, everybody, this is like, oh, of course, we have this and we have that. There is a social aspect to this that I appreciate from the joke standpoint. Nobody wants to be the one that goes, no, we don't do it. So I'm going to say something that may surprise, especially if you're a technologist here. You really need to start, as you're approaching using deep learning to solve a problem, from the customer experience. You need to start with what is you're working toward, what's that final thing, and then work your way back. And if you have seen this in the context of things like software development and design, you've probably heard it, but it also applies to this field that we're in. You always must start with the back. And I mentioned a few minutes ago about the Adobe AI think tank that I've been involved in the last few days. And everybody in that think tank, there was lots of stuff we couldn't agree on. We could not all agree on what is the definition of AI. You get a bunch of AI experts in the room, there was no consensus on that. We had some rough areas that we could agree on, but this is the one thing every person in the room agreed on, was that you need to start with your customer experience, period. So as we get started and we talk about how we're going to get there, how we're going to deliver deep learning, these are some questions to start with. Are we, first of all, culturally, in terms of the values that we have and the way that we want to operate, are we prepared to experiment, fail fast, and learn our way into success? That's a really hard question, because that's one of those things everyone says yes about, and then they don't do it very well. That is a huge, huge cultural challenge from the CEO all the way down through the organization. What problem are we trying to solve? What data do we need to solve the problem? Do we have the data? Where's it coming from? Where are we going to get it? I was attending Robbie Allen. I think I saw you in here somewhere. He talked, there you are. He talked about this in his session, and we have a lot of overlap, largely because Robbie and I both agree in terms of how we approach this world. It's a huge thing, and I'm going to talk about that a little bit more in a moment. Do we have enough of the right data to train the models? We have data, but is it the right data? Where is it going to be aggregated? Where is it going to be maintained? What pre-processing, post-processing is necessary on that data to make it usable? And what enterprise and data architectures are going to be used? These are wide open questions, especially that last one. If you put 20 different organizations in the room, they're all approaching it in different ways. So here's what I always start doing. After I focus first on my customer, the next thing is I analyze the problem statement, and I say, can I solve the problem with simpler, less expensive tools? And there's a reason that I start here. Because right now, most people think of AI as magic. That includes most people in industry. This great tool, it can solve everything we've ever wanted to do. It can't. It's a toolbox. It's a really powerful toolbox, but it lends itself really well to some problems and not so well with others. And there may be a whole bunch of problems out there that, yes, you could solve it with, but it's more expensive than in terms of what you'd want to do. So what I'm really saying is that deep learning is often the wrong solution to your problem. And we're going to talk about this a little bit more when we get into process. So why would it be the wrong solution even if it can solve the problem? Because deep learning automation is expensive to implement at scale. Deep learning automation requires a strategic investment from the leadership of your organization to go do it right. So you start off by trying to recruit the best people you can find, and realistically, you're often going to train the best people you already have and bring them up to speed. And I can't emphasize this enough. You've got to create a learning culture, because in deep learning, it's not like a process where you say, Robbie mentioned in his talk about software development is becoming fairly well understood, and I think that's a great point that he made. It is unknown if you're going to get to the right model. It is even possible, according to the mathematics of this, that you can do all the right things and still not get an answer, even if it is the right kind of problem. So you have to create a learning culture in your organization where failing fast is not only is acceptable, but it's expected of you. To where you hit the wall, you bounce off, fall down, you pop up, you run forward in what you think is the next direction. You hit a wall again, you fall down, you get up and keep running. I tell people on my team, be a weeple. Remember weeples? Weeples wobble, but they don't fall down. So when you hit, you bounce back up. Bounce, 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 and bounce your way right into the right direction. And that way, you're doing it quickly, because every experiment is affecting the bottom line of your organization. You are spending money on every failure. You have to use failures to get to the right place, but you have to be cognizant of that. You owe that to your company. But they also owe you the recognition that you're not likely to get there on your very first try. So we need a learning culture. Deep learning requires a lot of different roles to bring deep learning into effect, and to make it productive, and to make it useful, and make it the right thing to serve your customer experience for your customers. There are data scientists, There are data engineers, very, very different roles right there. There are software engineers, because we have to deploy. There's a lot of aspects of deep learning that are not just the model. You have domain experts. You have to go off. It is so common for me to go off to different teams. Those teams that we're supporting on products and services at Honeywell, they don't necessarily know very much about AI or deep learning. We have to educate them. And I don't know very much about the products and services that they're creating, so I have to learn a whole lot. And there's a point there where you have to blend in your technical expertise and where it can be used with their domain level expertise, and that is universal in problem solving within organizations. I do that over and over again. There are also many other roles that I haven't listed up here just from space. But this is a big point that I want to make, and it's a mistake I see often with companies, is just because you have data scientists doesn't mean that they are experts in deep learning, or they may have a little bit of exposure. But whether you're bringing people in from the outside or whether you're training people up from the inside, you have to go and you have to analyze each of those people that are joining you and say, do they have the right expertise? Do they have the right skills? Do they understand the process? Are they able to implement that? And you have to bring them from a more traditional data science perspective into what it takes to deliver deep learning. So if you kind of bring some of these things that I've been saying into a unified thing, it's that we really are looking for that startup mentality. And when I said fail fast, the first time you probably heard that. So we really want to invent AI solutions. When you're failing and failing and failing and hitting the wall and getting up and running forward, every time you're trying to invent that new thing and you're working your way into the right thing. And in many ways, it is very much like software development in that you need to go get those requirements. What does my customer want me to do? Do I have the data, which is something in software development we haven't had to do prior to this? What is the right model that we need to do? Once I finally find the right model, how do I get it out there? How do I deploy this? What is the software that needs to wrap it? What's that infrastructure? How do I get it into my products and services so that I solve my customer's issue? So we need to be extracting through AI innovations, and this is the Wild West when I say that. That is a statement that I'm saying there's all sorts of creative ways to pull value out of data depending on what you're looking at. And one thing to think about is, I talked about the product teams. You need to go back and educate them. Are they thinking about their products the right way? They may be the masters of that domain, but you can go back and say, you know what? If you were to change design in this way or that way, then you will do better. You will serve your customers better. So there's a collaboration there with the product teams and service teams that has huge dividends down the road. And so startup culture, fail fast, learn fast, pivot fast, invent fast, and ultimately win fast. So you want to be strategic in how you're approaching this, disruptive. We at Honeywell are very competitive in how we approach it. We're very innovative, and we tend to think big. We got great tools, and we want to go for there. So to turn and shift gears slightly, I'm going to talk a little bit about some of the tooling. So you do not simply do deep learning, because there's data there that does not stop. And that's another point of education is it's so easy to say big data, big data, big data, but I don't think most people in industry realize the difference in scale, the difference in the orders of magnitude of data that you're likely to be dealing with on that. And so that creates a huge imperative, and that is that an executable AI strategy requires a prerequisite data strategy that is evolving and in place ahead of time. And that is where most organizations fail. In my view, I'm going to stop for 1 second. This is the single biggest place that organizations getting into it hit the wall. Is that they want to dive into AI because it's great. The marketing people are pushing. The CEO wants it. It is a fantastic thing to say, hey, we are investing our products and services with AI, and we are going to go out there and stomp our competition. But if you don't go do the necessary footwork to get your data strategy and your data infrastructure in shape so that the data is in the right place at the right time in a useful way, then you will fail. And that will cost a lot of money, and they'll be going, why did we invest in this? So But there's also really good news. We have all these open source tools that we're talking about, and this is democratizing deep learning so that it is accessible. And that's really, really a key thing. The number of people, I overheard an O'Reilly employee a little while ago talking to a client in a room that I happened to be in, and they were talking about how this is a small conference. And they were comparing it to some of the other O'Reilly conferences. I think Strata was the one. And what I'm going to point out is that over the next few years, I would expect this and other similar conferences to explode because the number of people that have access to this is going to explode. You're going to see it moving much more into software development and not strictly be in the context of data science in all cases because the tooling will do that. And as an aside, it's not on my deck, I was at NVIDIA GTC in San Jose a few weeks ago, and I had the privilege of meeting with NVIDIA's CEO for about an hour with there's probably about 20 of us in the room. It was a small group conversation for about an hour. And that was one comment that he made, is that he's expecting to see software developers really sweep in. That doesn't mean all software developers, but the number of people that will be able to implement these technologies with the new tools, and the tooling is racing along right now, will be just staggering in the years ahead. So these are some of those tools that we talked about. In no particular order. They're all great tools, and this is one of those, if you've heard the phrase bike shedding, where you're debating if A or B is better and everything, and everyone has their opinion, you can bike shed this all day. I have chosen, in the short term, TensorFlow mainly because it's the market leader. It's easy to get buy-in on it because, hey, it's by Google, and if you're a business person, that is an easier sell. It's kind of, when I was much younger, people used to say it's the IBM of this or that, and Google has taken over that position. And so I use TensorFlow, and we also use all three of the major cloud providers as we do this. And they all provide fantastic solutions. They all have great GPU offerings. But sometimes you have to also evaluate whether or not you want to do cloud. There can be a crossover. If you're doing a lot of deep learning training, there can be a crossover where it's actually worth it to go put your own systems into your own data center. We do both at Honeywell. Our R&D device is a DGX1. The DGX2 just came out a few weeks ago. But this is kind of what we use for our quick R&D, and then we support production stuff using the various cloud providers. Some of the other tools that I like to use that are also kind of built in is Docker, Kubernetes, and the one you probably have never heard of is Pachyderm, which is, you could think of it as a workflow system, sort of like Git for data. And we use Git as well. But these are some of the tools that I like to use. And then I want to, as we come toward a close and get to a point where we can have some questions, I want to talk the last few minutes about process. Have a process. There's a lot of different ways to approach process. They all have common things. If you look at 5 different processes that are well designed, there's going to be a lot of commonality. And so we start off by evaluating the business problem, understand it, make sure that you can measure what you're doing, and that your customer data is validated, because everything arises from that customer experience. Then we do data discovery. We kind of define what our data is, and data verification, where we understand our formatting and the visualization tools to understand what it is. We tend to blend lots of different data sources together from different places, and we map all that out before we ever seriously think about a neural network. We get the data in order, and then once we have that, we do a pre-assessment. We say, okay, I've just done all this discovery. I want to understand in depth what is my data able to support in terms of us solving the problem. And we go back and we'll even say, is it feasible to think of the solution that we're thinking of, that thing that's already in our head as we're moving forward? Is it feasible? And do we have target hardware to support the solution that we're interested in? With things moving out to the edge more and more right now, I can speak in my own company. We have so many products that are now thought of as edge devices. Honeywell's moniker is the power of connected. I'm not trying to sell you on that right now, but it informs you about our strategy. If everything is connected, everything becomes an IoT device. And so as we are thinking about pushing AI technologies out to the edge, what we have on the edge becomes really crucial whether or not it can support the technologies we want to drive through there. So assuming that the assessment comes out, and let's say for a moment that we do want to do deep learning to solve the problem. We do want to use neural networks. Then we go into data preparation. We do it through a deep dive that generates lots of questions to go back to product teams on to try to understand what they need. Is the data going to support the kinds of operations that we can provide? And then we validate, again, the feasibility of our solution. And you see that popping up over and over about feasibility there, and that's because most, in my view, I don't have numbers to support this, but I would argue that most deep learning initiatives fail. And depending on the culture that you're in, it may fail forever, or if you have management that understands what I was talking about a few minutes ago about learning your way into success, then maybe you're able to do that. I think that's a huge thing. So finally, we get to modeling. After all this talk and all this work, we start saying, what is our what kind of neural network do we want to create? What is our architecture? What kind of features? We have tons of data from everywhere. It may not be, even though neural networks are great for identifying the features in the training process, there's a cost to putting every bit of data you can into a neural network. So you are having to make a cost-benefit analysis up front in terms of what your engineering should be. Selection, training, evaluation, and this, in reality, this is a loop. It goes around over and over again through your training cycles as you iterate your way into a better and better situation, hopefully. And then finally, deployment. I only have one slide here on deployment, but I will say this is huge. We are tending to focus, because it's an AI conference, on deep learning and the neural networks and the model and stuff, but the amount of work that goes in to the deployment process and being able to support that after your team is done with their work, getting it out onto devices, whether they be servers in the cloud or handhelds or robots or whatever, and we do all of the above that I just said. You have to figure out, how am I going to wrap this? What's my target environment? What does it support? Do we have the skills we need to do that? Can we do them on our team, or do we have to go back to the product team to rely on them to do that? We have to negotiate every one of those, and that's just talking about software right now. Does the systems have the CPU, GPU, DSLs that we need to support operations? Does it have the data flows in and out? What are some of the other things? Do we have databases on those devices? What are our data feeds to our end devices? Forget training for a moment. After you put a neural network out there, it's consuming data all the time in production. Is that even in place? Have the product and services, those teams, have they thought about that? All that has to happen. And then as you iterate on these models, you have a TensorFlow model that's amazing and you're ready to put it out there. How are you going to get it out over time and iterate on that? Do you have CI/CD? Yeah, you have it for your other software, but is it incorporated into your deep learning engineering? All these are really big questions that you have to answer, and they are not easy and quick questions to answer. So as we finish up, I want to talk about that there's certainly a bright future for deep learning. It is being powered by these exponentials of amazing computation resource like never before, and the size of the data sets that we have available. But I also want to leave with two warnings in a moment. Clearly, the guys who wrote the deep learning textbook are basically saying in a very flat way that this is exciting stuff and it's going to grow and grow. And I think they're right, but two warnings. Ignore the hype. I don't know if any of you follow the Gartner hype cycle, but as of at least July, deep learning was right there at the pinnacle. And so if you're not familiar with this, the basic idea is it says every technology out there goes through this initial hype cycle, and then it's everything that could possibly save the world, and then obviously it's not. So, and people get frustrated, they invest a lot, they don't get a return on investment, and it plunges in popularity, and then people have a little bit more realistic expectations, and it manages to come out of the trough of disillusionment. I really like that name, personally. The trough of disillusionment. So in theory, we're somewhere, I suppose, into the trough of disillusionment, maybe bouncing out. I haven't really been able to detect this in a clear way in real life, but I keep trying. So if anyone has any comments, I'd love to hear those. But keep the hype out of it. It's a tool. You got a toolbox with a bunch of really good tools. They're not the right tool for everything. You don't want to make everything a nail for the hammer of deep learning. But figure that out in your organization, what works. And then finally, be thoughtful and responsible with these technologies. They're really powerful. They can be used for great good and terrible evil. And I'm not really addressing all those things, but it's such a powerful capability that we have, and we have no idea how to use it yet. And I think there's a role for every person who's a practitioner needs to be thinking, where is this going in my organization? And just as one thing, some of you may have seen this if you follow videos and stuff, there's sound to go with it, but let me see if, nope, didn't do it. So, oh well. It won't show. I was going to show it's deep learning driving drones in a weaponized sense. The DoD released in last January, just over a year ago, a video of drone swarms that are going after radar-created targets. So you have real drone swarms in the deserts of Nevada flying around, but the targets they're attacking are not real. They're painted, but it's amazing how they self-organize and go after these targets. And the reason I do that is some people go, oh my God, I've heard of swarms and stuff, but I hadn't actually seen a video of it being used. And this is the stuff that's not secret. So it's just to reinforce that. Be thoughtful about your use cases. There's a lot of unintended consequences we can have. So finally, I think I mentioned in the beginning, Practical AI is a podcast that is just starting up. We're just about to go live in May. We've done the first few interviews, and we're getting a group of them to go out. If you're a software developer and have ever listened to Changelog, this is part of that group of podcasts. And so I welcome you to listen. And that is it. Thank you very much. And feel free to connect with me. If you go to my website, it has all my social media stuff. So it's one, you can remember one URL. That's it. Any questions?
So I think we have only have time for only one question.
Quick question. How do you deal with the lack of explainability of deep learning models at Honeywell specifically, and how do you see that being addressed by industries where that's critical, like defense, financial services, and healthcare?
Yeah, it's a great question. We have obviously the same limitations that other organizations have in terms of compliance issues and such. And there are times when within Honeywell you'll have an industry that is our customer that we're serving that we simply can't. It will be like, you know what, this is a great neural network problem, and we just don't, because we can't meet the compliance regulation, although there's certainly often a lot of research. That's a big area right now. The explainability factor is a big area that a lot of researchers are trying to tackle. So I, along with probably many people in the room, are hoping that we get to a point where we can satisfy this kind of compliance requirements. Just a limitation. Thank you for the question. Any else before I got a minute or so?
You showed us the PC when you began to work with computers.
Yes, the original PC.
Yes, it had DOS, and at that time, Apple was also beginning to be known.
Yes.
But those two products, Apple and DOS, led the developments for until now. In deep learning, what will be the company or the product or the software that is leading and is going to?
Probably right now, I mean, there's a big battle, and I work with all the vendors, so at the risk of a vendor seeing this, I mean, I think it would be widely acknowledged right now that NVIDIA is kind of leading the way in the GPU space. Intel is certainly chomping. We work with Qualcomm. They're all there, but I think it would be widely acknowledged that NVIDIA is right now the leader in the space. Hopefully I don't get in trouble for saying that. Sure. Anything else? Oh, I'm sorry? I don't own any. I'm just being careful. We work with so many. I think last one?
Yeah, just real quick. So you said that oftentimes that the deep learning algorithm isn't what you typically use. So do you also parallel develop like traditional machine learning algorithms and
Absolutely.
test those out, and so that way you have something to go in
Absolutely,
parallel?
and we will have initiatives where we think it's a deep learning thing. We've gone through all the assessment, and then we discover as we keep learning our way into it that probably isn't the right solution, and we'll back into other solutions instead. So we don't have a religious fervor about it has to be a neural network. The right solution is the thing that should be implemented. Great question, though. All right. Thank you very much.